Okay, so this one. This section is 9.4, solving quadratic equations by factoring. So the first part is called the square root property. What the square root property says is anytime you have x squared in another term, so you almost never have two terms with x and you only ever have one after it's simplified, you want to solve it. So if you have x squared equals a number, how do you get rid of an x squared is you do the inverse. The inverse of squaring is square rooting. So I took the square root of both sides. Now, and right now it's just n, but if we can square root it, like square root of 9, we would write 3 because square root of 9 is a whole number. If you can't square root it, leave it as the square root of 5 because there's no square root, okay? Every time you square root something, you write plus or minus in front. So that's where I get the plus sign and the minus sign. The reason for that is because, think about it, 2 times 2 is 4, yes? Okay. Now, negative 2 times negative 2 is also positive 4. So 2 different versions of 2, the negatives and the positives, still made the same answer. And that's because 2 negatives make a positive and 2 positives make a negative. So anytime you take a square root, you always have 2 answers. That's why it's called square root. I mean, square means 2. So when we look at a very easy basic version, x squared equals 25. Get rid of squared, you take square root of both sides. X squared turns into x because the square root and the square cancel out. Square root of 25 is the whole number 5, and since I took the square root, I put plus or minus in it. On Alex, you have to write them separately, so you'd have to write x equals 5, comma, x equals negative 5, or x equals 5, comma, negative 5. You wouldn't have to put x equals twice. But you'd have to put that if there's no plus or minus button given to you as an option in that little box they give you on the side. Okay? Now, next thing, little harder. You have x parentheses, x minus 3 parentheses squared equals 64. So they're still squared, but more of it's being squared. So still, everything over here is being squared. So you have to use your order of operations. Well, to get rid of everything being squared, you square root both sides. 64 is still square rooted to be 8. I put plus or minus because I took the square root. Now I have x minus 3. Now what I would do is I would go, okay, how do I get x by itself? I'd add 3 to both sides. So that means x equals 3 plus or minus 8, and do the math. So 3 plus 8, 11. 3 minus 8, negative 5. Or you can make 2 equations, but I think that one is the best choice so you get used to the rhythm. Okay, next one that's just like that one is this one. So again, all of this is being squared. So first thing you do is square root it. So you get x plus 6 equals plus or minus, because I took a square root, and then 9. So then you write, okay, how do I get x by itself? Minus 6. You always put that number in front, and the reason for that is when square roots don't make whole numbers. So I have negative 6 plus or minus 9. So then you do that math. Negative 6 plus 9, well, that's 3. Negative 6 minus 9, well, that's negative 15. Those are my 2 different answers. They're very different from each other, okay? Next type of problem is right over here. Make sure you can see it. Okay. That is when whatever is being squared is not completely alone, so you can't square it right away. So you first go, how do I get rid of it so the thing that is squared can be alone? So this one has it has plus 7 on it. So you go, how do I get rid of plus 7? Well, you go, okay, well, what's the opposite of adding? Okay, subtracting. So subtract 7 from both sides. I have something in my eye while you do that. And then you have y plus 5 all squared equals 21, because 28 minus 7 is 21. So then, okay, cool, let's keep going. Take square root of both sides. I go, oh, in my head and in my calculator, square root of 21 is a decimal. It's not a pretty number. So we're going to leave it as a square root of 21 for now, okay? So leave it there and go y plus 5 equals plus or minus square root of 21. So go, okay, how do I get y by itself? Move that 5 over. I get negative 5 plus or minus square root of 21. Now, if it doesn't specify what kind of answer it wants, you can leave it like that if you want. You might have to type in negative 5 plus square root of 21 and then negative 5 minus square root of 1, but it's still a correct answer. Now, if it says give me the decimal form, and it usually says 2 decimal places, or the hundredths place, whichever way it wants to be the most correct, you just type it in. So you would literally just type into your calculator, right, like negative 5, oh, I have to cancel out of that, negative 5 plus the square root of 21. And it would give you decimal, and then go to last place. And then negative 5 minus the square root of 21, okay? This one is the same thing. First, want to get rid of that 3 because the square is not by itself. I have something in my eyeball driving me crazy. Okay, so we have a minus 8 all squared equals 13. Square root, you get a minus 8 equals plus or minus square root of 13. Move the 8 plus or minus square root of 13. We type that into our calculator. When I added them, I got 11.61. When I subtracted them, I got 4.39 with rounding, because that one rounded up. And then that would be my answer, that's it. The last one is just like that, but instead of adding and subtracting right away first, you're gonna have to divide. So you see that 4 in front, you're gonna say, okay, how do I get rid of it? You divide both sides by 4. Well, that's good because that's a whole number. So I have m plus 1 all squared equals 9. That's nice. Get rid of the square root by squaring square by square rooting. So you get m plus 1. Ooh, that's a square. That's a perfect square root. Plus or minus 3. So you have m equals negative 1 plus or minus 3. So then negative 1 plus 3 is 2. Negative 1 minus 3, negative 4. Okay? Next section, we're going to take our concept we use about everything we've done with quadratics and just set it equal. So the zero property rule, okay, zero product property means that if you have two things multiplied and they're set equal to 0, that means one of those things must have to be equal to 0, because if not, it wouldn't work, right? Because anything times 0 equals 0. Okay, so if you look at the first one, it's already, well, let's make sure you can see it. It's already done for you. You have two sets of groups. Okay, and you see how they're already simplified? So you want to say, can I simplify this? Nope, they're already done. So you just set each group, anything that's separated by parentheses, equal to 0. So 2d plus 6 equals 0. 3d minus 15 equals 0. And then do 2 steps of basic math. And see what you get. When you solve both of them, you get two whole numbers. You get d equals negative 3 and d equals 5. Okay? Now the next one's a little different, and I went a little sideways when I solved the problem. Now, you have c squared minus 3c. Now, if you notice, that one does not say equals 0. That means we have to make it say equals 0. So just like the last section, we're going to take that 3c and move it over. So that's what I did. So I have c squared minus 3c now equals 0. So I go, is that simplified? It is not, because these guys have something in common. So I'm going to pull out a GCF of c. So I pulled a c out, parentheses c minus 3, parentheses equals 0. So now it's simplified. You set everything that's separated by parentheses equal to 0. So the c in front, set it equal to 0. Well, there's your answer, c equals 0. Set this one equal to 0, c minus 3 equals 0. Set it, you get c equals 3. So those are my two answers. Same thing right here. This one, now this one, is this already simplified? These, 3n by itself can't be simplified, and n plus 2 can't be simplified. So you set equal. 3n equals 0. Well, that divide by 3, you still get n equals 0. That one was easy. N plus 2, set that equal to 0. Subtract the 2. You get n equals negative 2. Those are your two answers. Now these last two, you have to actually solve. You go 8 and 40. Do they have anything in common? Yep, the number 8. B squared and b. How many b's they have in common? They both have at least 1. Let's write what's left over. 8 divided by 8 is 1. B's take 1 away, you have 1 b left. Negative 40 divided by 8 is 5. How did b take away? That's all's left. Equals 0. Now that this is simplified as much as it can, you set each separate part equal to 0. Got the hiccups now. Divide this, you still get equals 0. You move that 5 over to the other side, you get b equals 5. It's just basic math after you figure out if it's simplified. So this is just all GCFs. We're just doing the easy stuff right now. Then this next one, again, look at it. Is it equal to 0? It is sure not, so we need to move this over. X squared plus 10x equals 0. So then we go, what do they have in common? X. Okay, then I have an x left, plus 10, set equal to 0. X equals 0, x equals negative 10. Okay, make sure that when you move this over, this turns into plus 10, because some of us forget, we go, oh, that was negative, and you write minus 10 again, so then our signs, the number is going to be right, but the sign is technically going to be wrong. okay? Now, there is more to this. We just did all GCFs there. Now, all this page is, and I'm just gonna let you look at it, and I'm just gonna remind you, once so I can make sure you can see all of it, of your methods of factoring, okay? Now remember, you can always do GCF. We just did a bunch of 2-term ones, but you can always find a GCF. If it only has 2 terms, first look at GCF, then go, okay, is it a difference of squares? If it has 3 terms, there should be two things you think in your head. You always go, is it a perfect square trinomial? Always think of that first, because remember that shortcut that I showed you in the last chapter? That should be written on your note card. You should hold that. Unless you have it perfectly memorized, it should still be written there. If not, you can always factor it the old way. Again, look up how to do that. I wrote it here, just in case for a couple of them, okay? And then 4 terms, the only option for 4 terms is grouping, okay? Make sure in the right order, and then group. These 5 problems have a few different ones. Most of them are factoring, but we got difference of squares, perfect square trinomial, and then these all are factoring. This one has grouping. This one has a GCF and a factoring, but these are all the ways. And you still, after you factor them, because it says equals 0, set each equal to 0.